Hello everyone, this is Mrs. Snook with section 5.4, a point slope form. And our objective is to write and graph linear equations using point slope form. And the neat thing about this form is that it uses any point on the line and the slope of the line. And what we've done before this is we've given you the slope of the line and the y-intercept, which is a very specific point. But now we have the skill where we can use any point on the line. So take a look at this picture. We have an image of hot air balloons, and over time that balloon is decreasing in altitude, it's descending. And we're going to find out the y-intercept of this line. And that y-intercept is actually the height that the balloon had when it started. And all we've got are points to work with. We don't have the slope and we don't have the y-intercept. And this is the type of problem where a point slope form is really easy to use. So here's what the point slope form is. You need two things. You need one, a point on the line, and two, the slope of the line. If you have those two quantities, you can then plug into point slope form, which is y minus y1 equals m times x minus x1. Now, x and y are just the variables that you use in writing the equation of a line. x1 and y1 are coming from the point that you have on your line. And then slope, you can get it from rise over run. So if you have a graph, you can count up how many boxes and over how many boxes. Or you can use the slope formula, which you may remember is slope is y2 minus y1 over x2 minus x1. And you would use that if you have 2 points. So let's do some practice with this. We're going to write an equation in point slope form. We have a line passes through -3, 6 and has a slope of -5. So we have a point, x1 is -3, and then y1 is 6, and m is -5. So I'm just going to plug into my equation. Y minus y1 equals m times x minus x1. And this is your point slope form. Now put in what you know. Y minus 6 equals m, which is -5, times x. We're going to do minus a -3. Now let's just clean this up a little bit. So when I subtract a negative, so I'm subtracting a negative, that's the same thing as adding. So I'm going to say x plus 3, and that's my answer. Let's do another one. We have line passing through 8, -4. So x1 is 8, y1 is -4, and has a slope of 2/3. So m is 2/3. What's the equation of the line? Start with point slope form. Y minus y1 equals m times x minus x1. So y minus -4 equals m, which is 2/3, times x minus 8. Now let's clean this up. So please don't leave it like this. Go ahead and clean up. We have a minus a negative. Make that a plus. So y plus 4 equals 2/3 x minus 8. And that's your answer there. Okay, now the next thing we're going to do is we're going to graph these equations. I'm going to start off by putting in my x and y axes. So there's my y-axis. I'm going to put in my x-axis. Okay, I'm going to label them. So this is x, this is y, and each of these boxes is going to count as 1 unit. So what I need to do is go into my point slope form equation. I need to pull out the slope and pull out the point. So the slope is easy, that's 2/3. So I'm just going to write here m equals 2/3. Now for my point. Remember that it's y minus y1 equals m times x minus x1. So because of this minus that's in here already, when I see a minus here, that means I'm just going to take this 1. And same thing over here with the x. I have a minus 2. Just like in my formula, I have a minus. So I just pull out the 2. So my point is going to be the point 2, 1. Or you could think of it, if you want, as changing the sign. So when you see y minus 1, just change that minus to a plus and put a plus 1 in. So let's go ahead and graph. I have the point at 2, 1. So there's my point. Now I'm going to use the slope to get a second point. And the reason I'm doing that is when I go to graph my line, I need 2 points. Otherwise, I only know where my line starts and I don't know which way it goes. So I'm going to use the slope, rise over run. Slope is 2/3, so my rise is going to be up 2. That puts it here. And then my run is going to be a positive 3. So up to 1, 2, 3, right there. Now I'm going to grab my ruler. And I think of it as a start point and a direction. So I'm lining up my ruler with the point that I had to begin with, and then I'm going to angle it towards that second point that I got. And now I'm going to draw my line. Okay. We're going to take a look at another one. So slope is going to be negative 4/5. Now I need my point x1 and y1. Notice I have a plus 7 here. And because my form says y minus y1, I'm going to take that plus, I'm going to make it a minus. So my point is going to be at 4, negative 7. And when I go to graph this one, I'm adjusting the location of my axes so that I can make sure that I fit my graph on my paper. So here's my x-axis. Here's my y-axis. And like I said, I just adjusted this so everything would fit. I have a point at 4, negative 7. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Right there's my point. And now I'm going to use the slope, negative 4 over 5. So I'm going to go down 4. So 1, 2, 3, 4. That's how far down I'm going. And then I'm going to go to the right 5. 1, 2, 3, 4, 5. So down 4 to the right 5. Now I've got my 2 points. I'm just going to line up my ruler and draw in my graph. Also want you to notice that this slope is negative. So when you're sketching this, make sure that your graph is going downhill. That's an easy way that you can check. And on the other one, we had a positive slope. So my line should go uphill. Just give yourself a quick check. Make sure that your lines are going in the correct direction. All right, part 3. Now I'm going to use 2 points to write the equation. And I'm going to take these points from the graph. I have a point at 1, 4, and I have another point at -2, -3. And I'm just going to go ahead and pick one of those points to be the first point. So I'm going to call 1, 4 our first point. So this is x1, this is y1. And that means -2, -3 is our second point. So x2, y2. Now to go in point slope form, I need to have the slope. All I have is points. So I can do it by rise over run from my graph. I'm going to go up 1, 2, 3, 4, 5, 6. So I went up by 6, and I'm going to go over to the right. 1, 2, 3. I think I miscounted. Went up by 7, not 6. Sorry, it's a little blurry for me. But right 3 was correct. Okay, so that's one way to do it. The other way is to use the formula. Equals -3 minus 4 over -2 minus 1. I get 7 over 3. So either way, I'm going to get 7 over 3. Now the other thing I need to do is write my equation using point slope form. So y minus y1 equals m times x minus x1. So y minus 4 equals 7 over 3 times x minus 1. That one uses point 1. Here's point 1. Here's point 2. I can, if I want to, I can use point 2 instead. And if I did that, I would say y minus a -3, so that's a plus, equals 7 over 3, x minus a -2, so that's a plus, and this is with point 2. So notice, I've got 2 different answers. And that's because I used 2 different points. So one of the features of point slope form is if I use a different point, I get a different answer. So that would mean that since I can pick an infinite number of points on the line, there's infinitely number of answers that I can use. Next, part 4. This time we're going to use a table to write the equation. And guess what? This table shows the altitude of a hot air balloon. That same hot air balloon we started with. During its linear descent, write an equation in slope-intercept form that gives the balloon's altitude at any time. So what this means is we're going to have the slope, and we're going to have to figure out what the y-intercept is. And the easiest way I know to do that is to start at point slope form. And then we're just going to solve for y. And you'll see what I mean in a moment. So let's pick 2 points so that we can calculate a slope. And I'm going to pick the 10,640 and the 9,440. And the reason I'm choosing those is I actually find those numbers easier for me to read with my 50-year-old eyes. Feel free to pick any 2 points you want. So I'm going to do slope equals y2 minus y1 over x2 minus x1. y2 is going to be 440 minus 640 is y1. x2 is then 90, and then x1 is 10. So I get 200 over 80. Now please reduce that. Here's a simple, easy trick. You see I have these zeros here and here. That means I can easily divide a 10 out of both numerator and denominator. So boom, I take those zeros away. I'm left with 20 over 8. Now pull out a 4 from numerator and denominator, and I get 5 over 2. And this is negative. This 400 minus 640 is a negative 200. So I have a negative 5 over 2. That makes sense because my balloon is descending, so my slope should be negative. It's going downhill. I'm going to clean this up a little bit, make it easier to read. There we go. All right, now let's pick a point. I'm just going to grab the first one, the 10 and 640. So y minus 640 equals your slope, which is negative 5 over 2, times x minus 10. So now I've got my answer in point slope form. So check that off. Now I'm going to solve for y. And what I mean by that is literally I'm going to rearrange this equation so that this y is all by itself on one side. So the first thing I need to do is add 640 to both sides. So y equals negative 5 halves times x minus 10 plus 640. Now distribute that negative 5 halves, and I get y equals negative 5 halves x plus 25 plus 640. So here's my answer. I'm going to write it down here. I'm running out of room, so I'm just going to come down here. Y equals negative 5 halves x plus 665. So now I've got my answer in slope-intercept form. And the question is, what do the slope and the y-intercept represent? Well, the slope tells you how fast your balloon is descending. It's how far down it goes for each unit of time. So how fast balloon descends. And the y-intercept, which is b, that tells you how high the balloon was when x equals 0. So where the balloon started its descent. Okay, so let's quickly scroll back to the problem that we started with. Right here, here's that balloon. And what we're saying is this y-intercept right about there is 665. So the highest point the balloon was at, the altitude where it started, is 665. Let's do a quick sanity check. Does 665 make sense? Well, I have 640 here and 680 here. It's right in between. That's exactly where we would expect it to be. So that's it for today's video. Thank you for watching, everybody, and have a great day.